All right, welcome to Chapter 10, Significance Tests for a Difference in Proportions. Up to now, all the testing we've been dealing with one parameter and one sample from that parameter to check it. We've been using one sample. Well, now we're going to do two samples, and we're going to compare those samples to each other. We're going to run an experiment here. We want to know, is yawning contagious? The good news is someone else ran this experiment. They did it on Mythbusters. So we're going to watch a quick little video from Mythbusters.
So how are we going to test whether or not yawning is contagious?
Well, first we need a test audience.
We're going to have to isolate them and be able to watch them with hidden cameras.
And we're going to have to be able to control this. Let's say it's a room. We build a room.
We're going to have to plant a yawning seed in the room as well.
You mean somebody who's in on the gag? That's good, okay.
I think we can put an ad out on the internet looking for extras, and then we just don't tell them what they're here for. That way we can get them to go sit in a waiting room and we can start messing with their minds.
Yawning is involuntary. The mouth opens and the jaw drops to allow in as much air as possible. As the lungs fill to capacity, stomach muscles contract and the diaphragm is pushed down. The heart beats up to 30% faster. Then, when the lungs are full, excess air is expelled. This time, they are testing one variable only, the seated yawn.
Sorry, moving up some support. Back to your room.
Well, come on in, follow me. Get in the little room quietly, and I'll come get you briefly.
There's 3 yawn cubicles, each fitted with a hidden camera, and one observation chamber, where Tori is on watch. Carrie will yawn at 2 of every 3 subjects as she ushers them into their cubicle.
So we're going to see if they yawn faster with some influence than without any. Every third person will be a control, which Carrie will give no influence to, and we'll see if there's actually a difference.
So the experiment begins, and Tori gets down to some careful observation of the subjects doing nothing. Absolutely nothing. It's starting to seem like the Mythbusters are just way too much fun to evoke even the slightest yawn. Then, a breakthrough. And after the drought, a flood of yawning is unleashed. The Mythbusters suddenly have the Midas touch. Even the local dogs get caught up in the current of yawns that's sweeping the market. The experiment also suggests that some guinea pigs are more observant than others. And finally proving that all good things must come to an end, 5 hours and 50 test cases later, the Yawnathon draws to a close.
That was it. That's the last one. We're done.
For Carrie, it's not a moment too soon.
I was yawning all day, to the point where my cheeks were hurting and my eyes were watering.
All right, well, after testing 50 people in the field, our largest sample we've ever used on Mythbusters, the results are in. And when the people we tested got no seed yawn, no stimulus, they yawned 25% of the time. When they got stimulus, they yawned 29% of the time.
Well, it's not dramatic, but it seems like it's pretty good to me. What do you guys think? Busted, plausible, or confirmed?
Given how large our sample was, I'd say it's confirmed.
There's little doubt, it does seem to be contagious.
And I bet the audience at home right now is probably yawning.
There's no privacy anymore. Nowhere to have a meeting. And it's just...
All right, so we're going to look at this another way. They said that this thing was confirmed. And really, what is it we want to know? We want to know whether or not there's a significant difference between 29% and 25%. And they said yes. And basically they did it just by looking at the two numbers. That wouldn't fly on our AP exam. You really need to set up the 4-step procedure that we've been doing every day in class. So we're going to state, plan, do, and conclude. And we're going to see whether or not there's a big difference between the 29 and the 25. First thing we do is we state, we're going to test whether or not P1 minus P2 is equal to 0. That's our null hypothesis, where P1 is the true proportion of people like those who yawn when given a yawn seed. P2, true proportion of people like those who yawn when no yawn seed is given. So basically what they're saying is you're testing people similar to the ones that are in this experiment. That's real important because we're going to talk about that over on the right-hand side where it says important. Our alternative is we think that P1 minus P2 is greater than 0. Another way of saying that would be that P1 is greater than P2. We're going to do all this at the 5% level. And over where it says important, it says most experiments use recruited volunteers, not randomly selected subjects. So researchers cannot generalize the results to a larger population. Instead, we're going to draw conclusions. We're going to make cause and effects conclusions that apply to people similar to those that were in the experiment. So let's plan. We're going to use a 2-sample z-test where we're going to do P1 minus P2 if our conditions are met. Same conditions as always, random, the 10% condition, and large counts condition. It seemed like they used randomness to assign which one got the yawn seed and which one didn't, which was basically what you needed to do. 10%, there's no real reason to have it because we're not sampling without replacement. In this experiment, again, you don't always need that 10% rule. The large counts, the number of successes and failures, we're going to have to do p hat times n and q hat times n for each of the 2 samples. You notice that we are not greater than or equal to 10 for these. So really, we shouldn't be using the normal curve, but we're going to do it because that's basically what this chapter is about. They should have used more test subjects to get those numbers higher. They said 50 was a lot. In reality, it really isn't that many. They should have used a few more so that they could test this. All right, in our calculator, we go to the tests, and we're going to do a 2-prop z-test. And we're going to see if P1 is greater than P2, where 10 and 34 are 10's the number of people who yawned out of the 34 that had the seed yawn, and 4 out of 16 for the non-seed yawn. You see our z-score is 0.324, and our p-value is 0.37. That's a high p-value. What do high p-values mean? Well, high p-values mean to us is that because the p-value is greater than alpha, we fail to reject the null. We do not have evidence that people like the ones in this experiment will yawn more often after seeing someone yawn. So, based on what we found, no, there isn't a significant difference. They think there was, and they confirmed that yawning is contagious. The funny part was I did an experiment like this with my son for his science fair a couple of years ago, and I'm going to look at those data and show them to you in class so we can look at and see whether or not we felt yawning was contagious. So, based on their information, I would not go around saying yawning is contagious. But I'm sure there's many other tests out there. And we'll look at the book, and we'll talk about a couple of different ways we're going to do things. All right? That's it.